Hi students, welcome you all with another new MCQ. It's an important MCQ. All of the following are uncouplers except thyroxine, thermogenin, 2,4-dinitrophenol and oligomycin. So what do you think is the answer? Yes, the answer is oligomycin. Yes, so we'll see few concepts on this uncouplers. So thyroxine, thermogenin and 2,4-dinitrophenol are uncouplers. Okay, so let's see the different types of uncouplers. One is physiological uncoupler, the other one is pathological uncoupler. Physiological uncouplers are nothing but thermogenin in brown adipose tissue and thyroxine. Pathological uncoupler is 2,4-dinitrophenol and ionophores, as well as aspirin salicylate can also act as uncouplers. Now what are these uncouplers? It uncouples oxidation from phosphorylation. Okay, they are those compounds that uncouples oxidation from phosphorylation. So let's see how it does that. So we all know what is oxidation. Here in electron transport chain, what happens? There are four complexes. Through these four complexes, the electrons move from one complex to the other. Electrons from NADH and FADH2. It moves from one complex to the other. Now as the electrons move from different move through these complexes, the final acceptor is oxygen, which converts it into water. Yes. So as the electrons move from the one complex to the other, some amount of energy is liberated. This energy is used in pumping out protons from the mitochondrial matrix into the intermembrane space. From the mitochondrial matrix into the intermembrane space. So the protons from the matrix enters the intermembrane space as and when the electrons move from one complex to the other inside the electron transport chain. Is it clear? Now thus what happens, a proton gradient is established. Yes, a proton gradient is established between the intermembrane space and the matrix. Is it not? Now this is nothing but the electrochemical gradient. This is nothing but the electrochemical gradient. Now this gradient is responsible for the proton motive force. Yes, this gradient is responsible for the proton motive force, which drives the protons which are now in the intermembrane space through the ATP synthase complex, which we call it as the complex 5, into the matrix. Yes, so the proton motive force helps in driving the protons from the intermembrane space into the matrix through the complex 5 or through the ATP synthase complex. Now as the protons move, what happens in the energy which is liberated is used in phosphorylating ADP to form ATP. Yes. So actually what is happening? The oxidation is coupled with phosphorylation step like this. Okay. Now as uncoupler, in uncouplers what happens? The proton gradient is dissipated via different transporters other than the ATP synthase complex. So now what you should understand, only if the proton gradient is dissipated via ATP synthase complex, ATP can be synthesized. So if the proton gradient is dissipated through some other complexes, through some other transporters or some other channels, what happens? Even then proton gradient is dissipated, the energy is liberated. This energy is liberated as heat, but ATP synthesis is not established. Okay, so that is why we have, this is the uncouplers actually uncouples this oxidation from the ATP synthesis or from phosphorylation. Alright, so let's see about these uncouplers now. If you take thermogenin, it's an uncoupler protein 1. Okay, so thermogenin is activated through it cold in response to cold or after eating. Okay, so this uncoupler protein, what does it? Forms a channel on the inner mitochondrial membrane. Now as the protons are pumped out from the electron transport chain, this happens. Okay, the electron from the electron transport chain, protons are pumped into the intermembrane space. Now these protons, instead of getting inside the ATP synthase complex and forming ATP, what happens? It gets inside, it is transported into the matrix via thermogenin or the uncoupler protein 1 channel. Okay, so even here the proton gradient is dissipated. Yes, the proton gradient is dissipated. So as the proton gradient is dissipated, the energy is liberated. The proton gradient is dissipated, energy is liberated. That energy is nothing but liberated as heat. Okay, it's liberated as heat. That is why thermogenin is responsible for non-shivering thermogenesis. Okay, it is responsible for non-shivering thermogenesis. Okay, so this is most thermogenesis. It's mostly concentrated where? In the brown adipose tissue. Yes, brown adipose tissue. It is brown because of its higher concentration of mitochondria, and in there the thermogenin uncoupler protein 1 channel is present. Yes, this gives you heat. Okay, this gives you heat. So where do you think, in who do you think this will be in more concentration? In newborns, is it not? Newborns need warmth, is it not? So for that they will have the more concentration. They will have more concentration of this brown adipose tissue containing thermogenin. All right. So non-shivering thermogenesis. So there is more of heat loss. To prevent this heat loss, there is one mechanism called non-shivering thermogenesis in the newborns. Okay, in the newborns. So hypothalamus, it increases with increased sympathetic activity. It releases norepinephrine brown adipose tissue. Also thyroxine stimulating hormone. Okay. So this now stimulates uncoupler protein. So even if it is brown adipose tissue or thyroxine, it releases thyroid hormones from thyroid, both of which stimulates the uncoupler protein 1 or thermogenin, right? So this thermogenin is now responsible for uncoupling oxidation from phosphorylation. As it does this, the energy is liberated as heat. Okay, so the whichever warmth is necessary, the newborns get through this process. So that is why thermogenin is an uncoupler, as well as thyroid hormones or thyroxine is an uncoupler. Thyroxine is an uncoupler. So both of which are physiological uncouplers. Okay, both of which are physiological uncouplers. Now look at this. This is nothing but the drug 2,4-dinitrophenol. 2,4-dinitrophenol. Yes, how does it act as an uncoupler? In the intermembrane space, it can easily pass through the mitochondrial membrane. Okay, so in the intermembrane space, it accepts the proton. Okay, in the intermembrane space, in the electron transport chain, will pump out all the H plus into the intermembrane space. So in the intermembrane space, this dinitrophenol will accept the H plus from the intermembrane space. Yes, it can easily dissipate through the or easily traverse through the mitochondrial membrane into the matrix, where it can release the H plus ions into the matrix. It can release the H plus ion into the matrix. So thereby this process also dissipates proton gradient, but the proton gradient is not dissipated through ATP synthase complex. So that is why ATP synthesis is not occurring. Okay, so this 2,4-dinitrophenol uncouples oxidation from phosphorylation or from the ATP synthesis. Okay, so previously this was used as a drug for weight loss, but now due to its side effects, it is because it is an uncoupler, is it not? So it is toxic and dangerous. The cells can be depleted of ATP. So due to the various side effects, it is not being used now, right? So this is the mechanism of 2,4-dinitrophenol. Also, we all know about ionophores, is it not? Ionophores. Ionophores form channels on the membrane. Yes, ionophores form channels on lipid soluble channels on the membrane to allow ions inside. Yes, to allow ions inside. So if ionophores form ions, channels on the membrane, what happens? The H plus the protons can get dissipated. The proton gradient can get dissipated through these ionophores. Thereby ATP synthesis is uncoupled. Okay, thereby ATP synthesis is uncoupled. Now what are the different ionophores we know of? Valinomycin. Yes, valinomycin and gramicidin. Okay, valinomycin and gramicidin. So these are the different ionophores. So ionophores are those which form channels on the membrane, so that for allowing ions inside, okay, for allowing ions through the membrane. So thus what happens, it will dissipate the proton gradient in the mitochondria, but this proton gradient is dissipated through these ionophores and not by ATP synthase complex. Thus oxidation is uncoupled from phosphorylation, right? So these are the different uncouplers that you should know of, right? So for this, the answer will be, the uncoupler is thyroxine, thermogenin and 2,4-dinitrophenol, and it is not oligomycin. Then what is oligomycin? Oligomycin is one that will inhibit the ATP synthase complex. Okay, ATP synthase complex. How does it inhibit the ATP synthase complex? ATP synthase complex has two components. One is the FO component, which is embedded on the mitochondrial membrane, and F1 component, which is protruding inside the matrix. Now O is nothing but it stands for oligomycin. Okay, so oligomycin is that compound which inhibits the FO component of the ATP synthase complex. Thus it inhibits ATP synthase. It is not an uncoupler, it inhibits ATP synthase. Alright, so oligomycin is not an uncoupler, it's an inhibitor of the ATP synthase complex. Alright, so let's meet again with another MCQ later, right? Thank you.